Hello everyone. Good morning and welcome to your yet another physics class. Today is 23rd of September, physics. We will be continuing the last class that we were doing in the previous class, the combination of the resistors. In that we have learned two or more than two resistors can be combined in two ways, that was series and the parallel. And previous to that, before that, we had also discussed some formulas and the terms on the EMF of a cell, the terminal voltage and the voltage drop. Now in today's class I'll be focusing mostly on the numericals based on these formulas that we have learned. So first of all, just a quick recap of the combination of the resistor, series and the parallel. In the series we have learned that the resistors will be combined one after the another. Suppose these are the three resistors, and in the parallel the resistors will be kept on one on top of the other, or one end will be connected to the same point and the other end will be connected to the other point. These are the two ways of combining the resistors. In this we have found the equivalent resistance to be the sum of the individual resistors. Just simply sum, and it is observed that the total resistance will be always greater than the individual resistance, and in the series we have found that there will be only one current that will be flowing. Okay, so we have got same current, and in the parallel the equivalent resistance is given as the sum of the reciprocal of the individual resistances. Okay, so this was the formula, and from the formula, since it is a reciprocal, we find that the equivalent resistance will be less than the individual resistors, and here the current is not same, it is splitting into individual section. So what is same here? The potential difference remains same here. So these are the two formulas, and using these formulas we will be doing the numericals. That is given in page number 201. There are about 13 numericals. I will be solving few of them. Okay, now in the case of the this I'll discuss afterwards. So let us start the numericals now. So all of you, we will turn to page number 201, and there are numericals. In all these numericals, the formulas that will be used is, we have already discussed that. So the first question, page number 201, numericals, question number 1. Okay, in the first question there is the setup given to you. I'll just make the diagram. In the diagram you have a battery there. This is a battery with the positive and the negative terminal, and inside that there is an internal resistance. Okay, and it is connected to the ammeter. Ammeter is the instrument to measure the flow of the current, and from this positive terminal, and there is one external resistance given to you. This is internal resistance, and there is a plug key here. So this is a setup. This is the positive and this is the negative. Then you have the voltage, that is the potential difference, and the EMF of the cell is given by the symbol epsilon. Now this is a diagram given to you here. This is a cell. From the cell, now what is happening, the current is being produced or current is drawn, and there are two resistance. This is inside, internal resistance, voltage drop, and this is external, outside the cell, and this is the terminal voltage outside the cell, and this EMF epsilon, we have known all the symbols. So in the question given there is, you have the EMF is given to you as 2 volt, and the internal resistance small r is given to you as 1 ohm. The internal resistance is given to you as 1 ohm, and the external resistance is given to you as 2 ohm. Now there is also a clock key given to you here. So what will be the readings of the ammeter and the voltmeter? So this is an ammeter and this is a voltmeter. Okay, so we have to find the readings of these two. That means, what does the voltmeter do? Voltmeter is an instrument which is used to measure the potential difference across the end of a coil or a conductor. And what does the ammeter do? Ammeter is an instrument to measure the flow of current in the circuit. So when there are two conditions. First condition is when the key is open. That means the circuit is not complete. So when the key is open or when the key is switched off, that means the current will not be flowing. So what will be the reading in the ammeter? Obviously the reading in the ammeter will be 0 ampere. So reading in the ammeter will be 0 ampere. Okay, because there is no current flowing when the key is open. Now when the key is open also, the potential difference in the external terminal will also be not there, but the potential difference across the entire cell when the circuit is not complete, that is called the EMF. Alright, so here what will be the reading in the voltmeter? The reading in the voltmeter will be the value of the EMF. So what is EMF given to you at the beginning? It is given to you 2 volt. Did you understand what happened here? Okay, so the reading in the voltmeter will be there, but which reading you will take into account? The EMF, that is for the entire cell. If you recall that we have learned that EMF of a cell is the potential difference across the entire cell when the circuit is incomplete. That means when it is an open circuit. Okay, so second case. Now when the key is closed, now that means it becomes a complete circuit. So when the complete circuit is there, the current will start flowing. So now you have to find what will be the current and what will be the external terminal voltage V. Okay, so for that, what are the values given to you? Here the current is not given, epsilon is given, EMF, what is this? Internal resistance is given to you, external resistance given to you, and the terminal voltage is given to you. So now for this, you have to go back to that EMF of a cell, and there was a relation which you have learned. So that relation will be used here. Okay, let me rub this so that it becomes, we can write the value afterwards. So if you remember that, the voltage drop is equals to EMF minus the terminal voltage. Okay, this was the relation we have learned. So from here, EMF is given to you, how much we got? Then it is given to you 2 ampere. Now you have to find this reading in the voltmeter. Now here we have to find when the key is closed, you will not take the EMF, you will take this terminal voltage. So we have to find that reading first. Now this is I into internal resistance. But here we have a problem. The current, how much current is flowing also we do not know. And what is this terminal voltage we also do not know. So from the Ohm's law, we can replace this as V upon R. Now we can solve it. So if you see there, this V is not given to you upon what is the resistance given to you? Resistance is given to you 4 into R. What is the EMF given to you? Sorry, internal resistance is also given to you. What is the value of internal resistance? 1. EMF is given to you 2, yes or no, minus V. So this V we can find here by doing the cross multiplication. So if you take this LCM, you will get 5V by 4. So if you cross multiply, you will get 8 by 5. 5, 6, that's 30. So you will get 1.6 volt. So what will be the reading in the voltmeter? So in the voltmeter, the reading will be 1.6 volt. Now, what will be the reading in the current? So current we can find easily now. You can use this formula. We will take only for the external. V, we got just now 8 by 5. The external resistance is how much? It is 4 ohm. So you get 8 by 20, or you can cancel this. 4 2s are 4 5s are 2.5 means 0.4 ampere. So the reading in the ammeter, the current that is flowing from the circuit will be 0.4 ampere, and the reading in the voltmeter, that is in the external terminal of the cell, will be 1.6 volt. So this is the situation when the key is closed, when the current is flowing, because we have, this is the formula which you have to remember. So like that, there are other problems also. In all the problems, the formula will be this only. So you can do this. So now let us go to another question. Question number 5. In question number 5 also you have to use this EMF of a cell. If you read that question number 5, it is given there. Let me rub this quickly. It is in same page number 201. Question number 5. A cell of EMF and the internal resistance sends a current of 1 ampere when it is connected to an external resistance of 1.9 ohm. So there is a cell, okay. So you have no need to make the diagram, but still I can make a diagram here. It has an internal resistance and there is a external resistance, and let us say there is a key, and this is a EMF, okay. So we have two situations here. In the first case, a cell of EMF and the internal resistance. It is not given how much is that. So EMF is epsilon and you have internal resistance of small r. It is sending a current. So in the first case, current is given to you 1 ampere and it is connected to an external resistance. External resistance is given to you 1.9 ohm. So this is the first situation. In the second case, it sends the same battery. It is sending a current of 0.5 ampere. So this is the first case. And in the second case, the same cell, it is sending a current of 0.5 ampere and the external resistance of 3.9 ohm, and the external resistance of 3.9 ohm. Now you have to find the value of this EMF and the internal resistance. So we know one formula, it's quite simple. The internal resistance EMF is equals to total resistance into current. So here the total resistance will be external plus internal into the current I. So in both the formula will be used same. like this. Okay, so now you substitute the value because these are EMF will be same for both the cells. So what is the external resistance? 1.9 plus R we do not know, yes or no, and the current is 1. Okay, then here also the external resistance is 3.9 plus internal resistance we do not know, and the current is 0.5. So now it will be 1.9 plus R, make this equation 1. You can open this and multiply 3.9. 3.9 into 0.5 is 1.95, I think, yes, plus 0.5 R. Let us make this equation 2. Now what do you observe here is both the EMF is same. Both the EMF is same, so let us take that 1.9 plus R equals to 1.95 plus 0.5 R. If you cross multiply, you will get that 0.5 R equals to 1.05, like this. Sorry, 0.05. So R will be 0.05 upon 0.5. So if you substitute, you will get 0.1 ohm. So you get 0.1 ohm. Yes or no? Yes, 0.1 ohm. So the internal resistance is 0.1 ohm. Now you can find the EMF from the first equation. So it will be 2 volt. Okay, so EMF will be 2 volt. Like this you have to solve the rest of the numericals. Now I'll be doing one question where you have the combination of the resistors using the formula of the series combination and the parallel. In some cases you have the series and the parallel combined together. Look at question number 10 now. In question number 10 you are given around 4 resistors which are connected in both the series and the parallel. So diagram is very important. Let me make the diagram here. These are the 2 resistors connected. Then from there you have something like this. Then 2 more resistors are connected like this. Then you have the end B, and this is the end A. The 4 resistors, the value of all the 4 resistors given to you 2 ohm. This is also 2 ohm. Okay, so now you have to find the equivalent resistance between the point A and B. That means the 4 resistors you have to reduce it and make it into a single resistance, and that will be your equivalent resistance. Okay, so now let us name this as R1, R2, R3, R4. So if I start from A, we see that R1 and R2 are in series. So these two can be clubbed together and make it into one. So let us write like this. R1 and R2 are in series. So when in series, what you do? You just add them. So let us give another name this as R dash. R1 plus R2. So R dash will be 2 plus 2, 4 ohm. So now see what happened here is these 2 resistors is combined. This has become R dash. So now we have reduced this 2 into 1. Now only 3 are left here. Okay. Now when you reach here, the current is splitting into 2. That means R3 and R4 are connected in parallel. So we can do like this. R3 and R4 are connected in parallel. So you have to know the formula in the parallel. What happens? We add them the reciprocal to get one equivalent resistance. So let them add this to, and let us make this as double R dash. So in the parallel, the sum of the reciprocal. So we get something like this. So 1 by 2 half plus half is 1 ohm. So if you reciprocate, you will get R dash as 1 ohm. So this is your R dash and this is your R double dash. So we got 1 ohm. So now this 2 is also reduced, and finally we will get, this is A, we get R double dash, this is B. So now what is happening here is this 2 has reduced into 1 by using the series. This 2 is reduced into 1 by using the parallel, but between A and B there are still 2 resistances, and how are they connected? In series. So therefore, equivalent resistance between A and B is given by, let us say, R. Now since both are in series, R dash plus R double dash. So what is the R dash you got here? 4. What is the R double dash? 1. So the answer will be 5 ohm. So like that you have to go on doing it. So these will be there will be different types of combinations. There are many questions which have come in ICSE. In the next class I am going to solve few for you, but the basic idea is to you have to find the equivalent resistance. That means now whatever resistances are given in whatever combinations, there will be a mixture of the combinations. Your main point is to reduce them. So you have to start by taking the one which are in series like this here, and these two are in parallel. Then again the final 2 are in series. So we have to know the formula of equivalent resistance in series and the equivalent resistance in the parallel. Please go on doing all these numericals. Whatever numericals is there up to question number 10, we have solved only 3, 1, 5 and 10. The remaining 7 up to 10 you have to do it. In the next class I'll be discussing some more problems from the ICSE. Thank you very much.